Okay, what was the first set of numbers we talked about yesterday?
Regular.
Natural.
Natural. Throat's dying. I was like 1, 2, 3, 4. Da, da, da. Okay, and N stands for natural. The next set,
Oh.
whole. That was almost the same. It just included 0, and W stands for whole. They use like a fancy W, but we're just going to use capital letters. What came after whole numbers?
Integer.
Integers. Integers included all the whole numbers and their opposites. Okay. Did we talk about what letters stood for integers?
Z.
Integers? It was a Z.
That.
Okay, after integers came
Real.
rationals. And this definition is a little trickier. Rationals are A over B, where A and B are integers. So basically it's anything that can be written as like a normal fraction. A over B, where A and B are integers, B can't be 0, you just can't divide by 0. So that would include decimals, because like 1.2 is like 1 2/10 or 5/4 or 6/5. Yeah. Anyways, decimals, repeating decimals. So like 3/4, 0.5, or -2.7. These are all can be written as fractions. 8, because that's like 8 over 1. Repeating decimals. This is like 5/9, I think. Anyways, rationals are almost everything. So all natural numbers are inside the whole numbers. They're called a subset. Natural numbers are a subset of whole numbers. Natural and whole fit inside the integers right here. So they're subsets, and integers fit inside rational numbers because you can just put all these over 1 to write them as a fraction, including 0, because 0 over 1 is still 0. Okay, so that means everything above this line. Oh, rationals, I don't know if I mentioned this yesterday. Q stands for rationals. So that means everything above this line is actually rational. Just natural is a more specific way of saying, is a more specific set because it has fewer elements. Whole is more specific, integers is more specific. But everything up here is rational. Does that make sense? This fits in this, fits in this, fits in this. Okay. And then if it's not rational, it's called irrational. And the symbol for that is, you put a little accent on it, means not rational. Irrational, the famous one is pi, and then most square roots are irrational, except for when are they not irrational? When it's like square root of 9, since that equals like 3, that's actually irrational. So that'll go up there. All right, and every number together that we've ever seen altogether is called real numbers. That's a fancy R. I don't know if you guys remember Algebra 1, but sometimes the answer was all real numbers.
Yeah.
That's what it's
That
called.
was a long time ago.
And well, it's going to be used again, but that was the symbol we used for it.
That was a yoke.
It's so weird, like just 3 months ago we were doing algebra.
Geometry.
Wait, no, yeah, algebra 1.
Yeah, it was a year and 3 months ago you were doing algebra. We did a little bit of algebra last year.
We did a lot of algebra last year.
Okay, so on number 1 on page 5,
Number 1, oh.
state the most specific subset of real numbers to which each number belongs. Okay, 3. 3 is best described as a what number?
Oh.
Natural.
Okay, it is a whole, it is an integer, it is a rational, but what's most specific? Natural. Because these sets up towards the top have fewer elements, like this Naturals don't include 0, wholes don't include these. So you want to go higher up to be more specific. So the most specific set that 3 is in is natural. So on number 1, just put capital N. Okay. Number 3, 0.818, 818, the 1/8's repeating. So what kind of number is repeating? Yeah. All repeating decimals can turn into fractions, it turns out. So a rational is Q.
You want us to write thing or can you write the word?
I guess you could write the word if you want. Number 5, square root of 15. Where does square root of 15 go?
I think it's irrational.
Irrational, because it doesn't simplify. So it's a weird number. So irrational, you write the rational Q and then it's a not symbol. Basically it means not Q, not rational. Okay. On number 7, the directions change slightly. It says state the subsets of real numbers to which each number belongs. So in other words, list everything that this goes in. So 0 for number 7 goes in what sets?
From natural to rational.
No, not quite. Yeah, the first time 0 appears as whole numbers. It's in integers. It's in rationals because you can write it as 0 over something. And that's still 0. So it's a whole number, it's an integer, and it's rational. Of course, all of these are real numbers, but I'm not gonna write the real numbers down. Number 9, 11/3 is a what?
Rational.
Yeah, that's like A would be. That's one of these. So it's rational. Is it anything else? No. It's not an integer, so it's just rational. Okay. So make sure, don't forget to do the evens on that page. And then we're going to jump to page 10. Oh, my feet are sore already. That's bad news. All right.
Wow, Skylar. I know, it was cool. Look at yours.
Okay. We talked about this in Algebra 1 a long time ago, but this is called a polynomial. You guys remember that?
Oh.
A one-term polynomial is like a monomial, binomial, trinomial for 3 terms. How many terms does this polynomial have? 3. Okay, they're basically separated, the terms, by pluses and minuses. So all this 3x squared is all like multiplied together. That's one term. X or 1x is one term. Minus 2, negative 2 is the third term. So this is trinomial. We're not writing down trinomial though because the directions didn't ask us to. We are writing down how many terms does this have. So the answer on number 1 is 3. Okay, now something we did not talk about in Algebra 1 is if you put parentheses around something, they just think of that as one term. So if they had put parentheses around x minus 2, they would think of this as just one thing because it's all kind of combined. So that would be like 2 terms. On number 3, that division bar kind of puts parentheses around the top and bottom. That's kind of what a division bar does. So that big old division bar, that's just one big term. So number 3 has 2 terms. How many terms does number 2 have?
1.
Just 1, yeah. Number 3 has 2 terms. See, number 4. Now, if they put a parentheses around it, they just think of it as one big thing. So number 4 is actually one term. Number 5, 1. Yeah, it has to be at least 1. Even 0 is a term. 6, yeah, 3. 3 to the x is 1. 7 minus x, because it's in parentheses, is 1. And 14 is 1. So yeah, 3 times. All right, back to the odds. Okay, I want us to try these without calculators. That's 7 through 12.
You said don't?
No calculator.
Excuse me, what?
Excuse me? Negative 12 minus negative 65. So, how could we do this? Negative 12 minus negative 65.
Negative 12 plus 65.
Right. Minus negative means plus.
So just 65 minus 12.
Right. This is the same thing as positive 65 minus 12. So 65 minus 12 is 53. Just this section, I'm not going to make you do that on the other section. Let's just try 7 through 12 without a calculator. 9, negative 11 twelfths plus 3/4. Okay, if it's fractions that you're adding, you need what?
Common denominator.
Common denominator. What do 4 and 12 both go into?
12.
12. So what do I need to do to the 4?
Times 3.
Times 3. Whatever you do to the bottom, you do to the top. So this becomes 9 twelfths. So you just add the numerators. What's negative 11 plus 9?
Negative 2 twelfths.
Negative 2 twelfths, which reduces, if you divide by 2, negative 1/6.
Where was this last year? Not here.
And we were in the same hour. This is the same hour. we were
Who's your
in
biggest class?
Last year,
those-
we had so many people in here that the air
It was
conditioner couldn't.
horrible. This is so nice.
Yeah, this is like.
It doesn't stink.
And Mr.
It's
You
not
might,
hot.
Skylar, you might start bringing a jacket.
Oh, I need to bring a fur, like a whole coat.
A fur coat.
I remember I would be in this plumbers class and I would just walk in here and I
Oh,
would
it's like a song. It's just-
Oh, during our class? During our class?
It was hot
Yeah,
and
we had to
smelly.
marinate. It was the smell.
It was hot, smelly, and humid.
Bring back the room spray.
You still have it. Miss Plummer walked in, immediately ran back to her classroom, grabbed the aerosol spray, and was like,
Yep. All right. So what are these symbols called?
absolute values.
And what do they do?
Make it positive.
Make it positive. And you kind of treat them like parentheses, like you do what's in them first and then make it positive. So absolute value of 10 is just 10. And absolute value of negative 4 is just 4. So on number 12, you would need to like do 7 minus 12 first and then do the absolute value of that. Negative 2 plus 9 first, do the absolute value of that, and then add at the end. So you kind of treat them like parentheses. Okay, 13, the directions say evaluate when x is 4, y is negative 12, z is negative 3. Wait, did I look at the right spot? Yeah, y is negative 12, z is negative 3. All right, and then 13 just says x, y. What does that mean?
4 times negative 12.
Means x times y. So yeah, 4 times negative 12, negative 48. 15 says y over z, or y divided by z. So that would just be negative 12 over negative 3. So what do we do with that? Divide. Fraction bar is also a division bar. Negative 12 divided by negative 3 is 4. 17 says, okay, this is the one that I think maybe half the class would get wrong. But you guys are lucky, it's odd.
I know when to think that.
You guys know why you get it wrong? Let me write it down. So, I'm just gonna plug in those numbers. 4 squared plus negative 12 squared if I plug that in the calculator, it would be wrong.
Because you have to put the parentheses around the -4.
Okay, right. Because we're supposed to square the y, we're supposed to square the negative. Y is -12, all of this. So we would need to put parentheses around that. Okay? Because if you just do -12 squared, it would just square the 12 and not the negative. But since we're squaring y, we want to square the negative as well. How about this 4 over here? Is this right?
No, you just want to parenthesize the 4 squared.
Okay. You don't put the negative in parentheses because negative is not part of x. You could put the 4 in parentheses, but that doesn't, putting one number in
No,
parentheses
not like that.
doesn't really do anything.
Parentheses on the 2 too. Like 4 squared on
Oh.
the
Well, that doesn't do it. That doesn't matter either because the order of operations automatically does that. But you don't need parentheses there. Technically, we should have parentheses here. Wait, did I copy the problem down wrong? Yeah, this is supposed to be a minus right here. Technically, we should have parentheses right here because we're supposed to cube all of z, but why does it not matter?
It's going to be minus anyway.
Right.
Oh, 'cause it's,
Because when you cube a negative, it's going to stay negative. So when you square a negative, that changes it to positive. This one would stay negative. Okay, so 4 squared, 16, the negative's untouched. -12 squared. And what's 3 cubed?
81.
No, too big.
Oh, wait.
3 times 3 is 9.
Negative.
9 times 3 is 27. So it's minus -27. So it's plus 27. Okay. And because the order of addition doesn't matter, you could do like 27 minus 16 is 11. 144 plus 11. Okay, number 19 says use the temperature conversion formulas to convert each temperature. Those formulas are written on the top of page 7. So it says C equals 5/9 F minus 32. Okay, what does this formula mean, do you guys think? What's this telling us?
This is how to convert Celsius or Fahrenheit to Celsius.
Right.
yeah.
You put the Fahrenheit temperature for F, subtract 32 because parentheses first, times 5/9, and that'll tell you what the Celsius temperature equals. So this is a Fahrenheit to Celsius converter. And then, did I write this correctly? As the other one. Yeah, 9 to C plus 32. This would be a Celsius to Fahrenheit converter. That one doesn't have any parentheses. So 19, it gives us 41 degrees Fahrenheit. So what do you guys think we should do with that?
Put it in the first one.
Plug it in.
Yeah, right there. So 41 minus 32 is 9. So 5/9 times 9. Those would like cancel out. So it's 5 degrees Celsius. So 20, of course, gives you a Celsius temperature, so the answer is a little bit weird on that one. Just
Wait,
Go
so
ahead.
is it C plus 32 times 905 or 905 times C
Okay.
plus 32?
well, you do order of operations, just like normal, so multiply comes before addition. That's why they put parentheses on the first one and the second one. Okay. 21, these are basically order of operations. You guys are going to help me with these. Does anybody want to volunteer to go first? Volunteer for tribute?
You use our calculators on these, right?
Yeah, but not the odds. We're going to do it together. Okay, so what is the trick to remember order of operations? PEMDAS? Sally. So P stands for
Parentheses.
parentheses. If there's multiple sets of parentheses, they start using what's called brackets and braces. But those are also parentheses. E stands for
The exponent.
exponents. Come next. M and D
Multiplication and division.
and A and S.
Addition and subtraction.
Okay, now these kind of go together because you don't really do multiply before divide and you don't do add before subtract necessarily. You just go left to right. So if I had like, let's say 6 divided by 3 times 2, you don't do the multiply first. You actually just do that left to right. So you do 6 divided by 3 times 2. Does that make sense? So these are actually tied. These are tied. Add, subtract, multiply, divide. All right. So, number 21. Anybody want to volunteer to help? All right. Timothy, what should we do first on 21?
6 times 2.
Okay, 6 times 2 is 12. What else?
And then you
10
addition.
divided by 5 is 2. So basically, we're just like saving the add and subtract for last. Okay, we just did that and that.
19 minus 2.
Yeah, and add and subtract, just go left to right. 7 plus 12 is 19 minus 2, 7. Okay, 23. 4 squared plus 6 divided by 3. Times 2 squared minus 18. All right, Eli, what do you think we should do first? Oh, it's 2 to the 4th. What do you think we should do first on this one?
23. Make negative 18 and normal 18.
Yeah, you could think of this as parentheses, so let's do that first.
And then you would have 4 squared as 16 plus 6 divided by 3 times 16.
Okay, yeah, so he did exponents next, so that was these two things. Okay,
And then 16 plus 2, or actually 6 divided by 3 would be 2 times 32, 16
yeah,
plus 32.
so we got divide and multiply right here, so you just go left to right, those are tied. 6 divided by 3 is 2, 2 times 16 is 32. And
30.
on 28, I'm going to say this before I forget. A division bar means you do everything on top and everything on bottom and then you divide. So that's different from a division symbol. These are not the same. So on a division bar, if you want to do it on your calculator, you could just put the top in parentheses and then hit the division symbol and then put the bottom in parentheses. That would do it correctly. But you're supposed to do the top first and the bottom first and then divide at the end. So you could fix that by putting the numerator and denominator in parentheses and replacing the division bar with division symbol. Okay, 25. 5 minus 2 minus 7 times. Minus 7 minus 5 times 2. Oops. Okay, so this one has brackets because parentheses are already being used inside here, so you could type this in the calculator just replacing the brackets with parentheses and it would work, but it's more confusing when there's multiple sets of parentheses, so that's why they write brackets. All right, Gianna, what should we do first?
The parentheses are the very inside first.
Yeah, inside the brackets,
Minus 2.
inside the parentheses, multiply. 5 times 2 comes first, so that would be 10. Now what?
7 minus 10.
Yeah, still in here, 7 minus 10 is -3.
And then 2 plus 3.
Okay, 2 plus 3 is 5.
And then 5 minus 5.
Skylar, we saved one for you. It's your time to shine. Okay, did I write that right? Nope. 2, 3 squared minus 2 squared. All right, Skylar, what should we do first? Okay. It doesn't really matter if you do this parentheses first or this one. So 12 minus 8, this will just be 4. Okay, how about this one? What do we do inside that parentheses?
3 squared minus 2 squared.
Okay, how do we do that?
Square 3 and square 2.
Right. Square these first, so it's 9 minus 4, so that would be 5. Now what?
And then we do 5 times -2. Or square 3.
Yeah, technically, it doesn't really matter because they're separated by minus, but technically exponents come first. 4 squared is 16, 2 times 5 is 10, so does this get out at 35?
Yes. 21. 35.
Next hour is 25.